So we just about to start at 5:10. So let us start. Good evening. So I hope you all stay till end because we have the live hiring test at end also. So just let me know, do you stay till end? Just let me know in the chat section. Yes, sure. Yeah, great. So I hope we are having around 51 participants right now. So I hope all of you stay till end because in end we have a hiring test. So listen carefully what your mentor is teaching. That might actually help you to land into your data science job. So let me start the session. So first of all, so show some excitement to our mentor. So our mentor of the day is actually here in the meeting itself. So let's welcome him, and show some energy and excitement to him in the chat section.
Hi everyone. So I am Tanmay. I have been working in the domain of data science for the past 3 years, and currently I am working as a data scientist at Gamezop. We are a real money gambling company, so feel free to log into our website and spend some money on it once you are done with the masterclass. And best of luck for the test that comes after it. Yeah.
Yeah. So welcome Tanmay for to have your time with us. So we are very happy to host you. I'm just starting the session, signing in the session. So I would like to welcome you for the Data Science Masterclass and happy to host you for today. And if you let, if we, sorry, I think I have some network issue. So let me introduce MyWays to all of you. So as you all know, MyWays, we are a tech platform where we are dedicated to make you experience freshers. So we actually provide various courses on data science, tech to tech students. We actually believe that we are here to bridge the gap between the employability and the students in the tech student. So we have a various new initiatives like My Gurukul, where we actually make the children's make all the tech students employable and have the employability opportunities for them. So our hiring test today is also in the initiative called My Gurukul. So I'll let you know more about My Gurukul and MyWays at the end of the session because we are soon to start a session by our industry expert today. So thank you so much, Tanmay, for joining in or for accepting our invitation. I hope you like our students have a great time with you and they get some value from the session today.
Thank you for having me. Okay, let's begin.
Yeah, the stage is all yours.
Okay. So is the presentation visible? Does it say Data Science Masterclass?
Yes, it is visible.
Okay, awesome. Let's begin. So what is data science? Data science is basically the sexiest job of the 21st century. The definition in front of you has been shamelessly copied from Wikipedia, which says data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from noisy, structured, and unstructured data, and apply knowledge from data across a broad range of application domains. This definition is an understatement as to how broad and how lucrative data science can be as a career path. The one distinct advantage data science has over all other fields is the broad range of its applications. Fast forward to today. So it was declared the sexiest job in 2012. Fast forward to today. There is no field, there is no company, there is no startup that is not looking to hire data scientists all across the board, all across levels, all across salary bands. As a data scientist, you cannot only switch domains, but you can easily switch countries. I have received offers from UK, Dubai, and many other countries, but I like India, so I'm gonna stay here for a while. Yeah. So moving on, the core agenda of today is going to be a subfield of data science, that is computer vision. So what is computer vision? deals with images, videos. Those are the two key pieces of data that we're going to deal with. And the data set that we're going to be using today is the MNIST dataset. So computer vision has found applications all across the board, from Formula One to healthcare to cancer detection to insurance even. So
Yes. Why did I part of it?
sorry, say that again. Achha, I think there's some sort of disturbance. Anyway, moving on. Insurance, how? KYC. If you submit your PAN card, if you submit your Aadhaar card, all of that is automated. Invoices, invoice reading. Banking, invoice reading, again, automated. So McKinsey worked with Formula One teams to design a computer vision suite so they can measure the time of a pit stop accurately all across teams, all across cars, all across seasons even. So if you know Formula One, cars change every season, right? So they designed a suite specifically with them and they made millions out of it. Sports, the Indian team as of today, the Indian cricket team uses data science and machine learning to optimize the performance of every single athlete. They are no longer cricketers, they are all performance athletes. Every single data point during training, during matches, during practice matches is collected and then inputted into computer vision applications to better improve their fielding style, their bowling style, their cricketing style, stuff like that. Okay, moving on. So the matter at hand at the MNIST dataset. This dataset was assembled by Jan LeCun, whose photo you see below in the slide. This dataset was assembled in 1998, and it has 70,000 images of handwritten digits. These digits were written by employees of the United States Census Bureau and high school students from the United States. Why was it assembled? Because before MNIST came in, there was no well-formed data set for computer vision. What do you mean by well-formed? A thoroughly investigated and high quality data set, which is labeled and standardized to a point where it can be used by anybody all across the globe. Before MNIST came in, all data sets were either very, very low quality, so they had very, very low quality images, or they were scattered all over the place. You had to visit like 10 websites to collect all of them. But Jan LeCun did his job, and he collected 70,000 high quality images uh, from these sources. So every single so if you see here on the bottom right, these are some examples of the digits that you will see in the data set. Moreover, every single image is 28 cross 28. So back in 1998, cameras weren't very high quality. So this is the best you can get. And to this day, no algorithm has been able to beat this data set. Beat meaning be able to achieve 100% accuracy on every single portion of the data set. Who is Jan LeCun? This man basically needs an introduction if you're into data science. This guy is the father of computer vision, and he has done groundbreaking research in data science, ranging from computer vision to world model building, stuff like that. He made what today is known as the state of the art, and he currently is the director of data science at Meta. Okay, so here on out, after every single slide, I'm going to take a pause, and if you have any doubts at all, put them in the chat or just open up your mic and ask me, because here is where the math begins. So today, the algorithm that we're going to learn is logistic regression. It's a very, very simple classification technique. So classification meaning, say you have emails, right? You have spam and not spam emails. So your algorithm is going to, given an email, your algorithm is going to classify whether the email is spam or not spam. But the problem that we have at hand today is classifying digits. So we are going to classify whether a given digit is a 0 or a 1. Now, this algorithm is a binary classification algorithm, meaning it can distinguish between 0 and 1. So any doubts regarding the algorithm, please go ahead. Okay, let me just check the chat once. Nitya, can you please check the chat once if there are any doubts?
Yes, I'll tell. I think it is not there right now. Yeah.
Okay, okay. So let's study the sigmoid function first. This is a very, very, very special function, and it is very dear to all data scientists all around the world. this is a function given any value is going to output a value between 0 and 1. Why is this special? Because every single time this outputs something, you can treat it as a probability. You can set a threshold of say 0.5, and above 0.5 you can say, okay, the value of fx is going to be 1, and below that it is going to be 0. And that is, this function is used all across machine learning, all across data science for classification tasks specifically. But if you're going to use every single real value it outputs, then that becomes a regression problem, where you output a real number between 0 and 1. But for classification tasks, you need to set a threshold above which the value of the function is going to be 1, and below which the value of the function is going to be 0, because you have two classes, class 1 and class 0. Any doubts, anything?
So there's a one doubt in the chat section. So it is about, please elaborate the linear regression.
Linear regression is not what we are studying right now, but
Yes.
linear regression is another algorithm. So linear regression is your for your regression tasks. So regression meaning you predict a value, a real number value between a certain range. So say 0 to 100, you're going to output a real number value. But for classification tasks, which is what we're studying right now, we are going to output a discrete value, 0, 1, 2, 3, so on. Yeah. Any other?
No.
Okay. I would highly encourage everybody to take notes from here on out, because everything coming forth is connected to the previous slide. So please keep in mind the function. Yeah. Okay. So moving on. This is our equation for the algorithm. So as you see here, is my mouse pointer visible? Nitya, is my mouse pointer visible?
Yes.
Okay, awesome. So this is our equation. This is your linear equation. So theta 0 is your constant value, x1, x2 are your variables, and theta 1 and theta 2 are your independent variables. So for the purpose of this algorithm, we are going to be tuning theta 1 and theta 2 given our data set. So our data set will comprise of x1, x2, x3, and so on. These will be pixel values. So since the image is 28 cross 28, we will have 784 pixel values. So we are going to have x1, x2 up to x784, and every single x will have a theta associated with it, which is known as a parameter. And then this theta 0, which is your constant value, is known as bias. Uh, and this combined with the g function is known as a hypothesis. So hypothesis meaning you are going to predict whether the given input of 28 cross of a 28 cross 28 image is a 0 or a 1. Your hypothesis function will tell you that. So as I pointed out earlier, everything coming forth is connected to the previous slide. Your g function is your sigmoid function. Your hypothesis will take for the form of this. Why theta transpose? Why are we vectorizing everything? For optimization purposes. If you are going to be using fast computers, you need to be able to vectorize every single equation that you have at hand, so everything can be done very, very quickly. So this is our hypothesis function. This is a linear function. We input it into sigmoid. We set a threshold of 0.5. Above 0.5, our hypothesis will take the value of 1, and below 0.5, our hypothesis will take the value of 0. Any questions?
Nope, there is no question in the chat
Okay,
section.
okay. I think we'll have them in the next slide. Okay. So now I have my algorithm. I have my 70,000 images. I predict for all 70,000 images. I get a prediction. Now I need something to measure how good my prediction is in order to improve the algorithm. For that, we are going to use something known as the cost function. Here, the cost function takes the form of the negative of yi log I. For those who are familiar with probability, this is indeed the expected value for output. Yi is your true label. So in case you input a 28 cross 28 image of a 0, your true label is going to be 0. But say your predicted value is 1. So yi cap is going to take the value of 1. And if you, since there are only two classes, if you expand the equation, it's going to take the form of this 1 minus y. Why? Because you have only two classes. So the probability of the other class is going to be 1 minus the probability of the predicted class. So for all 70,000 predictions, yeah, so for all 70,000 predictions, you are going to compute this loss value and output it to test how well your algorithm is doing. Any doubts, anything at all right now?
No.
Okay. So now you have an algorithm, you have a data set, you have an algorithm, you have a way to test the algorithm. Now, how do we improve it? You need to use the loss value that you had in order to improve the algorithm. If the loss value is high, it means the algorithm is not performing well. You need to be able to tweak these parameters, theta 1, theta 2, to be able to predict well in the future. For the next iteration of those 700 images, you need to tweak theta 1 and theta 2 using your loss. So you can predict better for the next iteration of the data set. How do we do that? We do that by using. Okay, so before that, let's discuss some properties of the cost function. Why is this cost function used? So for all purposes, this is a convex minimization problem. Why convex? Why not non-convex? Because uh, we need to model the problem in such a way that there is one and only one global minima. If we have multiple global minimas, then the algorithm will have problems dealing with them. Why? Because if your algorithm gets stuck on a global minima, on a local minima, then it will not be able to escape the local minima and go to the global minima. That is why this function is used. You can use any other function, but the one condition that is that it has to satisfy is that it has to be a convex function. Otherwise, your algorithm is not going to be able to perform very well. Another very key point here is that if the hypothesis is incorrect, the cost approaches infinity, and if the hypothesis is correct, the cost is almost zero. That is something that is very desirable in the cost function that we have right now. So we penalize the algorithm very heavily in case the algorithm predicts poorly. Why? Say you are predicting the probability that the patient has cancer. If the algorithm predicts incorrectly, you wish to penalize the algorithm very heavily, right? You cannot afford to predict wrongly in this case. That is why this cost function is very desirable, and it is used all across the board for classification tasks in general. So we have algorithm, we have a data set, we have our cost. We need a way to optimize the algorithm in order for it to be able to predict well, right? Here is where gradient descent comes in. Okay, so any doubts thus far before we go to gradient descent? Okay, gradient descent. So given your loss, given your optimization, given your loss, given your cost function, and given your algorithm, you are going to be differentiating the cost function with respect to the parameter you wish to optimize, and then you are going to subtract the derivative that you have with the current value of your parameter, and you're going to get the updated value of the parameter. The key thing to note here is this alpha parameter. Why alpha? Why do we not subtract the whole derivative? Because we want to take small steps towards the global minima. If we take large steps, you might end up bouncing here and there and not reach the global minima itself. We want to take small steps every single time we pass through the 70,000 images so that we can get to the global minima. If you work out the derivative, you'll get something of this form, where your hypothesis, and here's your hypothesis. For all samples, for all m samples, m being 70,000 here, you're going to process this and update your parameters. So let's put it all together. You have your hypothesis, you have your loss function, you have gradient descent. I get 70,000 images, I pass them in my hypothesis, I calculate the cost, I run gradient descent. This whole process, when done once, is known as one epoch, EPOCH. For every epoch, you will update every single parameter once. Parameter meaning this theta. You may or may not choose to update the constant as well. That is completely up to you. The bias parameter, the constant theta 0, you may or may not choose to update. For every single epoch, you are going to run the hypothesis, calculate the cost, calculate the derivative with respect to each parameter once and update said parameter when you get when you process the whole sample, when you process all 7,000 images. Okay. Uh, when do we stop? How many times do we go through the entire data set? It's completely up to you, and what sort of metrics are you tracking. If say my loss goes from 100 to 1 and it stays there for say 10 iterations, 10 epochs, I'm going to stop there and then. Why? Because I have no benefit of running the algorithm any further, because the loss is not increasing or decreasing in any way, shape, or form. But you can also limit, uh, say you are under some time constraint and you have only time for say 100 iterations, so you choose to run said algorithm for only 100 iterations as well. Okay. This wraps up the algorithm. Now we're going to move on to code. So any doubts, anything to ask here, anybody? Okay, awesome. Everybody seems to be very convinced by my uh, explanation of the algorithm. I was hoping for more doubts, but okay. So let me share the code. All right. Logistic Regression on the MNIST Dataset. So as always, I import NumPy, TensorFlow. These are standard imports. I do them all the time. To fetch the dataset, we're going to be using scikit-learn. Scikit-learn is another library. Almost all extremely popular datasets like MNIST, like Iris, like the Titanic dataset, stuff like that are very, very popular and can be fetched using the fetch OpenML function. You are more than welcome to check out the documentation for fetch OpenML to get to know what sort of options does the fetch OpenML function offer and what sort of datasets you can fetch from there. I would highly encourage you to do that, so to get an idea as to what sort of datasets are and can be built. So it returns a dictionary, and these are set keys for the dictionary. So for our purpose, we're going to be using the frame key. This has the complete dataset, and the labels are also attached in the dataset. So as I pointed out earlier, we are going to be dealing with only digits that are 0 and 1. So I very simply extract out rows that are only catering to my problem, that is zeros and one digits. So this is a sample of the dataset. Oh my bad. Yeah. So you have your 784 pixels and you have the class that is associated with them. To show you an image from the dataset, this is a 0 from the dataset. It's a 28 cross 28 0, black background and the white digit. It is a black and white image. It's not an RGB image. Back then in 1998, RGB datasets were very, very, very hard to assemble given the camera quality. The fact that Jan LeCun was able to assemble this dataset is in a feat itself. Uh, is all the work that he has done thus far is just the cherry on top. Okay, and the one looks something like this in the dataset. Of course, there are multiple types of ones and zeros in the dataset because multiple people have written these digits, and this is just a sample just to show you, just to give an idea as to what sort of data we're dealing with. Yeah. I separate out my my labels and my pixel values to train my algorithm. And I also normalize the pixel values. Why 255? Why not say 1000? Because pixel values and black and white images can go only from 0 to 255. And why are we normalizing at all? Because algorithms in general behave better when values of variables are normalized. This has been empirically shown. There is no mathematical proof, but normalization in general is a very good practice, especially if you're dealing with multi. So here, the scale of every single variable is going to be the same. Why? Because every single variable is a pixel value. But if you're dealing with multiple types of variables, multiple ranges of variables, so say You have two columns. One column goes from the range of 1000 to 2000, but another column goes from 0 to 10. Then normalization is not only good but necessary. Why? Because the algorithm can easily give more importance to the value to the variable that has a bigger range, both in terms of the width of the range, the scale of the range, and the absolute values of the numbers that the variable takes. Okay, so here is where I split the data set into two parts, my training set and my testing set. The model is going to be blind to the testing set. Why? Because you cannot test somebody on the same data as you've trained them on, right? If I teach a kid 2 plus 2 is whole life and I keep asking him 2 plus 2 as well, of course he's going to answer right every single time. So for testing the model, I need to show the model data that the model has never seen before. And it is very standard practice to have 2/3 of the data as the training set and 1/3 as the testing set. You are more than welcome to try out different types of splits, and I would highly encourage you to try different types of cross validations as well. So I have listed two here. This is your classic, the method that we've been using here is your classic cross validation. I would highly encourage you to go ahead and look at k-fold cross validation as well as leave one out cross validation. What it is and how it is used, what are the benefits, what are the drawbacks, stuff like that. Okay. Here I will convert my data into NumPy. Why? Because TensorFlow does not like data frames. It has issues processing data frames. And yes, since TensorFlow enforces data types, I have to convert the data into float32 type. Why does TensorFlow enforce data types? Because its backend is written in C++. Why C++? It is the fastest language out there right now. It is faster than C even, which used to be the fastest before the modern version of C++ came in. Why not Python? Python is super slow. Python uses an interpreter and it has very basic multi-threading, and C++ has, since it's a legacy language, it's older than me. It's been used through and through, and the support of C++ is amazing as well when it comes to parallelizing and speeding up operations. That is why TensorFlow uses C++, and that is why it enforces data types. Python does not, but C++ does, and thus TensorFlow has to enforce data types. Here is your sigmoid, our beloved sigmoid function. Here is our decision boundary as well in yellow. So above 0.5, if our hypothesis predicts above 0.5, we're going to say that the class is 1. And if it predicts below or at 0.5, you can say that the class is 0. This is my model class. So I take 784. So I'm initializing them as 784 ones, and I've given them these variables the name of weight and bias as well. Your theta 0 for our purpose. And sometimes sigmoid is referred to as softmax. So don't be perplexed when you see softmax around. Yeah. I have defined the loss function here as well. Why clipping? So I am clipping by value here. Why? Sometimes it will not happen here, but sometimes what can happen is you can feed anomalous examples into the data set, which will really offset the loss by a very huge margin. So say your trailing loss, your loss thus far after processing 100 examples is say 10, but the 101st example is a very anomalous example. It can really offset the loss by a lot. Say it shoots the loss up by 1,000 or decreases by 1,000. So yeah, you really need to clip the value. Then here is your loss and your accuracy as well. I have defined the accuracy to be very, so I can use it to measure both my test and my training loss. Here we go. This is my training function. I would highly encourage you to go and look up the documentations of each and every single TensorFlow function I've used here. So SGD stands for stochastic gradient descent. It's a fancier version of gradient descent that we have encountered here. Gradient tape, I would highly encourage you to go ahead and look at these function definitions, what is their purpose and how are they used. in this piece of code for you to be able to understand the algorithm better. So we initialize the model. Oh my God. And I'm training the model for 60 epochs. Uh, just to give you an idea as to how model training actually works. And here is your loss. So we see the loss is plateaued to a value that is very, very close to zero, and thus we can say that our model has performed well. It is able to classify zeros and ones very well. Even though our assumption was linear, our model was able to perform very, very well, considering it the loss is almost at zero. Do you need to do all these fancy things in the industry as well? No, you can just go to scikit-learn and do this in 2 lines. You import logistic regression and you train logistic regression. That is just it. Why did I go through all this hassle? So that when you go through said code, you can easily relate this piece of code with the presentation that I've given you. Okay, that is all from my side. And please, yeah, the bias is a constant. Yeah. So your it's a linear equation, right? It's the equation is that of a line. A1 x1 plus a2 x, sorry, theta 1 a1, theta 2 beta, theta 2 x2, and so on, plus your constant. You can easily tune the constant as well, but it makes very little intuitive sense to tune the constant as well, right? Since it is known as bias, you're already pushing the algorithm in a certain direction for it to get started. If you're going to tune that as well, you're more than welcome to try it out, but it's seldom the case where we tune the bias as well. Yeah. Can I get I think you can ask Nitya regarding fetching the recorded explanation. And any questions, anything from your side? That is all. That wraps up logistic regression, and the last 20 minutes we've reserved for any sort of doubts you might have regarding the masterclass or data science in general, career paths, stuff like that. Yeah. Even my career path, you can ask me. You're more than welcome to ask me about my career path. What is the major role of a data scientist? It definitely depends on the organization that you work for. So data science really special. You are going to be the domain expert. You are going to be the person people come to for facts. So as far as Gamezop is concerned, I am the domain expert for the company when it comes to real money gambling. And I am also the person that they come to for facts, fact checking. So what sort of deposit rate do we have? What sort of engagement do we have on the platform? What sort of people are going away? So the problem that I solved very, very recently is known as churn. So if you come to the platform, you deposit money. My model is going to predict whether you are going to be uh, leaving the platform in the next 30 days or not, given your transaction history, given other sorts of data that we have at the platform. My model is going to predict using your data whether you're going to leave the platform in 30 days or not. That is the core job of a data scientist. And of course, there are many other application of data science as well in the organization itself, where I help make the organization a bit more data oriented. So every action we take has to be backed by data science, by A/B testing, by fact checking, stuff like that. What are the basic requirements to become a data scientist? I have said this once. I'll say that again. I'll say it again. You need not pursue a master's to become a data scientist. I do not have a master's under my belt. I have a simple bachelor's degree from Thapar University in computer engineering. Going for a master's is the classic route to become a data scientist, but there is no such requirement. I myself am hiring right now, and I do not look at the degree that the person has. I have hired an intern in the past. I did not look at the degree that she had, and we have had data scientists in Gamezop that have left us now, but they did not have masters as well. So the basic requirement to become a data scientist is have very, very good and in-depth knowledge of algorithms. What I gave you today is just a teaser of logistic regression. I can go on and on and about for logistic regression for 2 hours at least and give you every single nitty-gritty detail. Have very, very strong statistics, linear algebra, and your choice of algorithms. So you want to explore computer vision, you want to explore NLP. You need to have a broad set of algorithms that you know very well, but also specialize in something. So say you have I had an affinity towards computer vision, so I went on and studied object detection, stuff like that. During interviews, the interviewer will definitely poke and prod where your depth is. So you need to be rock solid when it comes to your CV. And making 30 projects is not going to bode very well. Have one good, very solid project that you worked on for 6, 7, 8 months. Pick a novel data set, pick a novel problem. There are plenty of novel problems to be worked upon out there, and do your best to solve it as best as you can. And leverage LinkedIn as well. LinkedIn is going to be your go-to to land a job in data science. Can you tell us how you started? Already decided. So I started the train test split is twofold validation. Yes, you can call it that. Very well said, very well pointed out actually. But in case of the twofold validation, your split is going to 50-50. So in case you split it 66, 36, 34, two-thirds, one-third, then is when your k-fold validation and so your two-fold validation and this classic train test split is going to be the same. Yeah. So in k-fold validation, say I am using 10-fold validation, I'm going to make 10 pieces of the data set, use 9 pieces for training and 1 piece for evaluation. And I'm going to rotate this 1 piece all across the 10 pieces. So I'm going to train on the first 9, test on the 10th, then train on 2 to 10, then test on the first, and so on. My degree, so I started in my second semester of college. I started studying data science then. Since at my point in time, there were not many good resources to study data science in general. It was all scattered, but now upgrad, Unacademy, stuff like that, they've come up with wonderful courses, 6 months, 1 year and there's a lot of free material there as well. I would highly encourage you to check out Stanford OCW and MIT OCW. That is something I relied on personally in my data science journey, and to this day I rely on to study data science, revise concepts, stuff like that. And one book I encourage everybody to read is ISLR. I'll type it in the chat. ISLR. Introduction to Statistical Learning. This is basically your Bible for statistics. If you are thorough with this book, you are never going to have a problem when it comes to uh, learning data science or statistics in general. But your linear algebra needs to be rock solid. Okay. In corporate, do we model our own algo or use some standard external packages? It depends on the problem you're tackling. If it is a novel problem, say you are in the biomedical field of research, then every single problem you're going to be tackling is going to be very, very novel in general. So you're going to be using TensorFlow a lot to code out your algorithms, but in corporate, almost all problems that you are going to tackle are not novel in nature. So you're going to be using packages a lot. I personally use packages through and through. I do not code out my algorithms by hand, but I do know what is going on inside that package. Because once you have a version of an algorithm, you need to tweak and improve it going further. And that is where your depth of knowledge related to the algorithm comes in. So for example, let's say I train logistic regression at my company right now. I get an accuracy of 80%. To take it from 80 to 90 or 95, I need to know every single corkscrew within the algorithm to be able to tune it well to my data set. That is where data science actually comes in. And of course, you need to go back to the data as well multiple times. You need to be able to tell what sort of biases, variance, what sort of properties every single variable has, what sort of properties every single row has in relation to the other, stuff like that. To study the data set in depth, to be able to come up with features that are going to be fed into your model, and then you get your result. You tweak the model, you tweak the data set to get better results then. Okay. How to choose between DS and SW for the future? I like them both. Been confused for a while. I would highly encourage you to explore software engineering first, then data science, because data science is very, very, very mathematical in nature. I have seen many people take up data science and quit in 3 months, 2 months, simply because of the amount of mathematics that is involved. What I showed right now is only just a teaser, a taste of what data science is and what sort of mathematics is actually involved in there. So I would highly encourage you to first, give software engineering a couple of months, 3, 4, 6, however much you're comfortable giving. And if you're not satisfied with what you are seeing in software engineering, then and only then will I recommend you explore data science. In no way, shape, or form am I discouraging you from exploring data science, or more than I had to flip it up, explore data science first and then software engineering. But that is my personal recommendation to everybody I have ever mentored. If they are pondering between two fields, software engineering or say graphic design X field and data science, I always encourage them to explore X field first, because to master data science to any sort of degree, you're going to have to spend at least 6 months on the study portion of data science. Yeah, you're going to have to learn linear algebra, distributions, probability, and statistics. Then you begin machine learning. That is the ideal path. Do we need to learn R for data science? No, absolutely not. I have zero idea as to how R works. I have zero idea as to how to install R for that matter. I have used Python through and through. Almost yeah, every single organization I have ever interviewed for uses Python. Every single organization that I know uses Python. R is mostly now centered around data analytics. So if you wish to go the data analytics route, then is when you can go about R. Hmm. Is DSA a mandatory requirement? No, it depends on the company you're interviewing for. Most companies, so consultancy companies like McKinsey, Deloitte, stuff, people like them, they do take DSA rounds as their first round. I think even Uber does for data science roles. For software engineering, Uber definitely does. For data science, I do not know. I'm not sure. So I have two separate instances to basis on. I have two friends. They both applied for data science role. One got a decent DSA assignment, a DSA test. The other one did not. So it's a bit dicey there. You're more than welcome to ask any Uber engineer on LinkedIn. You just go ahead and ping them and ask them. Just to don't ping one, ping at least 5, 6 people, because only one or two are going to respond. But you're more than welcome to go and ask. In general, no, but you need to know the organization that you are applying to. And if a DSA test actually arises, it is not going to be very theoretical, and you are not going to be using data structures like segment trees or graphs or anything like that. It is going to be very basic. It's going to be very logical in nature. The test that the DSA test that data scientists have to deal with, if at all. It's usually an assignment, a take-home assignment that is given. That is standard practice in data science. A take-home assignment. So Gojek does that. Gojek gives a take-home assignment that will take around 5 6 hours to complete. You submit it, and based on that assignment, your interview is going to be scheduled. Yeah. So there is an answer. How to learn DS in Python? The same way you learn DS in any other language. In continuation of the previous question, I am interested up to deep learning and it's my branch. Okay. But I feel I'm not getting that kick from it. So should I explore and try it as well properly too? So a pointer to be noted here is that deep learning is a tool. You cannot base your whole perception and your career of data science based on deep learning. As of right now, I have 6 models in production. None of them use deep learning. They are working in production right now. Deep learning may or may not get audited one day. Doesn't seem to be the case that it's going to get audited, but you never rely on just one thing to make a career, right? You have a holistic understanding of data science. You know linear regression, logistic regression, support vector machines, knife base, these basic techniques, XGBoost, boosting, trees, random forest, these basic techniques that the machine learning was built on, and then you explore deep learning. But if you're not getting the kick from it, then I think you should explore software engineering as well. Try it out. Yeah. I'm an electrical department student. Which language is Python? Python is your go-to. Python is going to be asked. Python is going to be used every single time you have to do anything related to data science. I heard that from the two data scientists that they have to use two languages, Python or any backend. So you are going speaking to a machine learning engineer. Machine learning engineer is also responsible for deploying the model that they've built. So a machine learning engineer definitely knows ins and outs of any backend framework that they're going to use to deploy uh, the algorithm that they've built. A book that I highly recommend you check out is A Field Guide to Data Science. I have put that in chat. A Field Guide to Data Science. It is 100 or so page book. It will give you a very good idea as to what data science is, how to learn, and it is about DSA in Python. Boss, DSA is about exactly what it says: data structures and algorithms. The language you use to code said algorithms and data structures is completely up to you. If you're going down the competitive programming route, I would highly encourage you to go for C++ because it's an extremely fast language. Almost every single good or highly ranked competitor in competitive programming uses C++. Resources are tremendous. You can go to Geeks for Geeks. You can go to institutions that offer courses in data DSA. How do you apply for internship organization? Does it currently have any basis? Just DM me or resume on LinkedIn. We are not hiring for interns right now. We are hiring for full-time data scientists. But in the future, if I hire interns, I will definitely post it on my LinkedIn. So stay in touch. Did you consider software engineering as a career? No, never. I was totally into data science in the second semester of my college. I never, so as a person pointed out, I never got the kick from it. Am I the only one who see the book's name in the chat? None of my messages are showing. Okay. Acha, I am sending everyone in the meeting. 1 second. ISLR and uh, Introduction to Statistical Learning. And the second book was A Field Guide to Data Science. I hope it's visible now. These are two books that you must read for data science. ISLR is my Bible. To this day, I refer to it. How's the work-life balance? Excellent. Right now, these are my working hours where I'm presenting to you. You get the idea, I think. It's for my organization, we are completely remote. We do have our head office in Gurgaon, which is going to open soon. I'm going to visit it for some time, but then I'm going to continue my remote work as well. What is the use of MS? Okay, so these are tools. These tools are used for data analysis. I, as a data scientist, have never used these tools. Why? Sometimes it's just the fact that the volume of data that comes in. So I have a friend who works for Microsoft. He is dealing with petabytes of data. These tools are never going to be able to process that. These are tools meant for dashboarding, for A/B testing, for project managers and analysts to collaborate on tools to build dashboards, to track metrics, to track business metrics. These are tools that are used for data analytics, not for data science. Yes, it is absolute. It is an absolute must. Doing a project. So you can go the classic route. You can go to your masters. But keep in mind that every single person who has ever done his masters is going to be the same level as you if you do not have a project under your belt. So you when you include a project in your CV, it takes your CV up a notch. And if it is a good project, say it is a research or publication, it will really be the shining star in your CV, and it will make for a very very healthy conversation and interview. What was your first role and company? This is my first company. This is my first role. I am a data scientist. Yeah. What is the use of Hive, Hadoop, PySpark? That those are tools used for data engineering. I have very very little idea about data engineering because I am a data scientist, very simply put. So you're more than welcome to go and explore data engineering as well. Sir, when did you graduate? 2020. So I had 1 year of internship from 2019 to 2020 in a bootstrap startup called Data Culp. I worked there as a data science intern for 1 full year, developed solutions for them, and for the past 2 years I've been working here at Gamezop. What project will be a good portfolio for freshers? Any project that is novel in nature, that you've worked on for 6 7 months, and that displays your depth in data science. Do not go for a project that you can build in a week. Okay, because I have seen more than 500 CVs at this point, and I have seen people with 100 courses listed in their CV with 70 projects. A 5-page CV it was. Did not hire the guy. What should be a project to comprise? Okay, so a good project, when I look at projects, a good project has a very good data set associated with it. So the data set is novel in nature and it solves some sort of novel problem. So the cliche route to go is the MNIST dataset, the cancer detection dataset, the Titanic dataset, stuff like that. So how do you look up datasets? You go to Kaggle and other sources as well. You can read research papers and ask the researchers themselves for the dataset. You can email them. They will be more than happy to give you the dataset. If the research paper is old, at least an year or two. If the research paper is recent, then they might hesitate to give the dataset. Then uh, you display every single ounce of your data science knowledge on that set data set. So you try out various algorithms, you build a solution. Once you have your final solution, you make it presentable. So say I work on a number plate detection algorithm. So it would be one thing if I just build the algorithm and call it a day. But if I want to make it presentable, I will deploy it somewhere and make a presentation out of it, a video out of it, showing actually how it works. Okay, there's a car coming in, my algorithm is getting the number plate and even reading it. And to take it another step further, pinging the Vahan API for the details of the driver. That would be the icing on the cake. So a car comes in, your algorithm detects the number plate, reads the number plate, pings the Vahan API, then you get the details of the driver. That is a very, very nice, high quality data science project. Uh, any other questions? And I would highly encourage you to make projects on technologies that are trending. So, for example, on the NLP side of things, how to apply for a company, ping me on LinkedIn. Observe that you're living in US, would you recommend it? Why? I'll come to that later. I would highly encourage you to try out projects on trending algorithms like BERT, stuff like that. Observe that you're using Linux. Yeah, in the industry, Windows is seldom used. So I would highly encourage you to get hands-on with any distro of Linux. I would Ubuntu is my go-to. But why? Because everything is open source in this ecosystem and very easy to install, handle, and deploy. Algorithms are seldom deployed in Windows. Windows server is very bad, and the ecosystem that has been built to deploy algorithms is written in Linux. Okay, we'll take one last question. I think we're out of time. What currently technologies do we have work? It depends on the job. So I have worked with both text and image data at my current job. It depends on the job and the project that I'm working on. Do not rely on working on a single type of data to build your career. That is the worst thing you can do, aside from learning only deep learning. Be open to working on all kinds of data, be it text, image, anything. What current technology do you work on? So at Gamezop, we use Redshift for our data warehousing purposes. So to store big data, we use Redshift. For our live databases, we use SQL, and for data science purposes, we use Python. Yeah, that's pretty much it. Python and Python servers hosted on EC2 machines. Okay, I think that wraps up the masterclass. Okay, yeah, that is all from my side, guys.
Thank you so much, Tanmay, for explaining our students very well, and like we are very happy to have you here. So now, as I have mentioned earlier, we are an edtech startup who just want to like made you an experience special to all our student communities. So we are currently with a new initiative known as My Gurukul. So here, what we do is we actually believe in training and placement at the same time. So we actually place students and train them on their job, and the fee price for this is absolutely free for students. We do not charge anything from for their training or for their placements. So I would like to give a quick intro of the My Gurukul, and then we just posted the test of the day so that they can give a data scientist test, our hiring test. Okay. So let me give. So My Gurukul is an initiative. It comes from the word My Gurukul. So it comes from in time where in ancient India there's a time when gurukuls were established. So gurukuls were actually made to be confident, conscious, and train you. So basically we are also trying to make students conscious, confident, and also train them for their educate them and train them for business. So all of them we are inspired mainly from our cultural roots, and basically we want our students to be placed at the company and learn accordingly. So this is our main vision or main idea behind our initiative, My Gurukul. So in My Gurukul, we actually give a one screening test to students. Once the students pass the test, he or she has to go under the one internal interview and one interview with the employer, our hiring partners. And then once the all three stages are clear, then the student is placed with our hiring partner company. So first 3 months would be training where you are getting a good amount of stipends, and after that you can get a PPO. So this is about My Gurukul. So hope you are liking it, guys. Just let me know, are you interested for the test? So I will just put out the test in the chat section. So just let me know in the chat section, guys. Yes. So yes. So this test. So here it is. So we have a test link in the chat section. You can give the test and come back. So we can have a one more feedback session. No, the test isn't about data science. So you have 15 minutes to give this test. I hope you give this test. And also there's a link of feedback form. If you have faced any problem, any doubt or anything, you can just feel free to fill this feedback. Our team will get back to you. Yes. Also, please do not forget to follow us on LinkedIn, visit our website and Instagram. And also, guys, do not hesitate to mention Tanmay on their LinkedIn and say that how good he teaches you a data scientist, teacher of data scientist. So please, Tanmay, can you put your LinkedIn link in the chat section also?
Yeah, sure, I'll do that. Here you go, guys. Here's my LinkedIn. Feel free to ping me. I am very active there. I'll be more than happy to speak with you.
And also do not forget to give him shout out on LinkedIn with MyWays, so that people can know that how incredibly he teach to you. So also please give the test and just let me know. Thank you. Timings to attempt the test is 15 minutes. So thank you so much, Tanmay, for joining in. We are very happy to host you and looking forward to host you in further sessions with MyWays.
Thank you for having me. It was a wonderful session. Bye bye.
Thank you so much. Bye. So guys, just attempt the test and let me know once your test is done. Sorry. Thank you so much for letting me know that tense link not open. Just try to open it once in the incognito mode. So guys, do you have any other query with MyWays, or if is are you able to give the test? And please, I request all of you to fill the feedback form. The test active timing is 15 minutes. So I'll highly recommend all of you to fill the feedback form so that we can know what it is, like what do you like, what you do not like. Yes, the Zoom meeting will be on. Like we are just here for like 15 minutes, so we will sign off at. Also, I have launched a one poll where you can tell us about the topics which you want for our upcoming sessions. Just let me know about that. which topics do you want for our upcoming sessions? Just Akriti, just let me check once. So also once you start there, please do not feel or do not change your screen. So because if you change your screen, then the test will not be able to open. So just try to once, not switch off your screen. I hope you people don't have any. Sorry, Sagar. Just try to give it from another ID, Sagar. So meanwhile, Alvin, you can actually give it from the another ID because you cannot switch the screen while giving the test. So please try to give it from the other ID. So guys, if you are not able to give the test or not able to have the test link, just you can fill the test form or you can ping us on our WhatsApp number so that we can actually give you a test link again. So I think that's all for the today and hope you please feel free to fill the feedback and we will give you a test link again. So I think it's all for the today. Thank you so much for joining in. In case of any query, feel free to connect us at student.connect@myways.ai. Student.connect@myways.ai. Hope you all pass the test. Thank you. Thank you so much.